First topic is EVPN MAC Dampening. So my name is Daryl. Together with me, co-presenting is Swati. And this is the agenda for this topic. I'll cover the overview, the use cases, some of the details, and hand over to Swati. She will cover the rest of the topic. Overview. So EVPN MAC Dampening is basically used to detect duplicate MACs in the network, right? So shouldn't have the same MAC address in multiple places. So that's the whole point. Right? And basically, once you detect these duplicate MACs, you can also provide a protection mechanism to prevent it from flapping, right? Endless MAC moves. You shouldn't flap from one VTAP to another. So before 10.6, currently in 10.5, we do not support it in the overlay. But 10.6, we will start adding support for EVPN MAC dampening on these platforms in the overlay. Use cases. Basically, it really helps prevent the MAC flapping, like I said before, between the VTAPs, if there's network instability or when hosts have been misconfigured with the same MAC address. For example, in a DC, a VM shouldn't do vMotion that many times, right? Within a few minutes. So by default, we are monitoring it for 180 seconds with a counter of 5. So that means if it doesn't hit that count, if it doesn't vMotion 5 times within 180 seconds, we don't think it's a problem. So that's normal, right? But if excessive vMotion, it should be a problem. So that's my point. Right, details. So basically, this MAC detection is on the same VLAN, same VNI. Right? Doesn't apply to L3 routing. It's only for bridging in the same VLAN or VNI. And AOS-CX follows this RFC for EVPN MAC dampening. And if you look at this RFC, this section talks about MAC mobility and the mechanism to detect such MAC moves on the network and how you can overcome it via MAC dampening. Important thing to take note of is every MAC mobility event for a MAC address will contain a sequence number. So this is the important part. Based on this sequence number, the decision will be made whether to withdraw it or send an update. Okay? So let's take a look at what this looks like. So this I have a leave 2 here. If you use this command, this MAC address, he basically learns it via EVPN. So the remote next hop is this IP, and it has a sequence number of 2. The flag is R. R stands for remote. Right? This MAC address is remote, has the sequence number of 2 with this next hop. And basically, when a VTAP has this MAC address, what it's going to do is it's going to update the sequence number. Right? So for example, this leave 2, now he has learned the same MAC address. It's local. He's going to update it to 3 and send this update to all other remote VTAPs. So that's what we're trying to say here. We're going to increment it by 1. And if a VTAP has this EVPN MAC dampening enabled and it hits it, it will withdraw its advertisement, right? So for example, if this is enabled with 4, a counter of 4, right? You wouldn't actually increase it to 4. You would just see it as 4 and stop sending it out. So that's why it will withdraw its advertisement. So some more visuals to help you understand it. So leave 1, you can see here, what I have in this diagram, I have the MAC of 88:CA, that's local on leave 2. So on leave 1, 88CA has a remote next hop, sequence number 0, flag with remote, right? That's what we expect to see on the remote VTAP. What about the local VTAP with the MAC address? You'll see this MAC address, sequence number 0 with L flag, because it's local. So the first MAC move, when it moves, you see leave 1, if it moves to leave 1 will actually update it, sequence number with 1, update it with flag L, and send that information to all other VTAPs. So leave 2 will now see it as, hey, this 88CA is remote, sequence number of 1, this next hop. Okay. So if it moves again, moves again, and if we set it to MAC count of 2, what happens is this guy, leave 2, will see hit the count. He will not increment it, but you have a log, duplicate MAC detected, right? So it actually hit the count, and you just stay as 1. So you actually hit the count, and it will not advertise it out. So that's what's happened. Right, I'll hand it over back to Swati now for the clearing component. Thanks. Yes. Good.
Okay. So you, as Daryl talked about detection of MAC dampening. So how it is cleared is what I'm going to talk about. So let's assume that it's a time t, which when the first MAC move has been detected, and for MAC X, okay, and let's say the configured values of MAC move detection is t and n. So the MAC is dampened if it detects n MAC moves within timer t. As in now, let's for example take t value is 180 and n is 5, which are these are the default values of MAC move detection. Let's say starting from time 0, if the first MAC move of x is detected at 0th second, the timer of 180 would be started. And if the fifth move is detected at 120th seconds, then the MAC would be dampened for another 60 seconds, which is 180 minus 120. So once the MAC is dampened, after 60 seconds, MAC dampening would be cleared for MAC X. And you would see it's exactly similar log or event log. How you had seen for a detection, you would also see for a that the MAC dampening is cleared. So to understand it better, so this is the timeline. Let's say here EVPN MAC is learnt or a dynamic MAC is learnt for a on a device, and for this device, first MAC move got detected at this point of time. As soon as first MAC move got detected, timer of 180 gets started here. And after some time, let's say the fifth MAC move was detected for the same MAC. Here, the MAC is dampened at this point of time, and here is where my 180 seconds, which was triggered, ends here. So, which means MAC is dampened for these many seconds, and once the 180-second timer is hit or expired, MAC dampening is cleared. So this means that this 180 second is used as a timer for both detection and clearing. So this is a common timer for both detecting and clearing the MAC dampening. Now, if this fifth move, whichever is here, is detected by a local learning event, which means that this device had an EVPN MAC, and he learned a dynamic MAC, and it was triggered. The fifth move was triggered, which means that EVPN will not advertise this MAC address. He will dampen the MAC. After 180 seconds, the MAC dampening is clear. He will then advertise the MAC out, generating a type 2 route. Now, if this MAC move is triggered by a receipt of a local route, remote route, EVPN will ignore that remote route and he will not withdraw its local route, which means he will not consider that remote route. He will also not withdraw its local route. Once the MAC dampening gets cleared, he will acknowledge that remote route and he will withdraw his local route which he had advertised before. So this is about clearing, and now we'll see what are the caveats present. So MAC dampening is enabled by default on these platforms, but default count being 5 and the timer being 180 seconds. This cannot be completely disabled. There is no form of the feature per se. So links to VTAPs need to stay up when validating MAC dampening. Example like shut no shut ports will not activate MAC dampening. See, MAC dampening is done only if based on the number of MAC moves, and this number of MAC moves is how it is detected is if you are having a EVPN MAC and now you are learning a dynamic MAC for the same entry, then it is considered as a first move. So in between, somehow if one of the MAC gets deleted, like EVPN MAC gets deleted, and later in point of time, if a dynamic MAC is deleted, that is not considered as a move at all. It is a fresh learn for a device. So in a way, it cannot be completely disabled, but if you're not looking for MAC dampening, you can play around with these timers, keeping the least timer and the highest value for the MAC moves, so that MAC dampening does not take into effect. But there are issues with VSX setup. VSX, the caveat being VSX primary dampens the MAC while VSX secondary still advertises it. So this is to be fixed in as planned for CPE. So let's go over configuration and verification. So there is no configuration required. It is enabled by default with 5 moves in 180 seconds. This configuration comes under EVPN context, where it's under EVPN you can configure this MAC move detection, both count and timer. So as I told you before, MAC move detection timer is also used as reference value for MAC dampening timer, as in for clearing the timers. So for from show logging, you can check this dampened one. These are the event logs that will get printed for both detected and cleared, and as well as the MAC for which it is cleared or detected. EVPN MAC dampening you cannot clear manually. You have to wait for the timer to expire, like I showed you before. So how do you verify MAC dampening? So if you can see in this example how Daryl was pointing out, dampened MAC is shown as locally learnt on both switches. Here if you see leaf 2 here actually has dampened, because you are seeing a dynamic MAC which is learned, and the same MAC he says he's learning from one more device, actually 24 1.24. So this guy has dampened the MAC because of a local learning. So he already has an EVPN route which is learned on L2VNI 10, and he has received a dynamic MAC. So he has dampened this MAC, which means he will not advertise a route type 2 for that. So this is how you can see on leaf 3, the one who is seeing the MAC moves between other leaf 1 and leaf 2. So when the MAC is dampened, he would still point to 1.24, which is nothing but the leaf 1's address. He would still point to the same 1.24 with the sequence number 4. But when the leaf 2 actually clears MAC dampening, he would actually update it to 1.21 with the updated sequence number of 5. So this is how output is seen by a leaf 3, the remote VTEP. So best practices. So default values are always suitable for most of the customers. If required, based on the requirement, we can modify count and timer values. Troubleshooting. So first would be to check our event logs, because we print out the events for detection and dampening and the clearing of the MAC dampening, and check for route updates, whether what kind of routes have been received by the device, whether it is local route or a remote route for anything, and then collection of the support files. So this is a check one I was talking about, event logs like we saw before, to see if MAC dampening is cleared or detected. And check two is to check whether this MAC IP route is received via show BGP L2VPN EVPN command, and if MAC is learnt locally or remotely via show EVPN MAC IP command. And check 3 would be to check if there are any errors that is present in EVPN dump fast log of routing, and then collecting the support log files. I shall show you all these things in the demo. So for example, let's assume we have 3 VTEPs, VTEP 1, 2 and VTEP 3. MAC moves are occurring between this VTEP 1 and VTEP 2. So on VTEP 3, let's say MAC is so and so is pointing to 2.2.2, which is nothing but our VTEP 2. MAC moves from VTEP 2 to VTEP 1 and gets dampened on VTEP 1. So from here to here it moves and it gets dampened on VTEP 2. On VTEP 3, this MAC would be pointing to 2.2.2 until or at VTEP 1 the MAC dampening gets cleared. So after the MAC dampening gets cleared at VTEP 1, VTEP 3 would be pointing to the right VTEP. Until then it will be pointing to the older one, that is VTEP 2. So let's get into the demo. So this is the topology that I'm going to use for today's demo. So this is a non-VTEP RR. Since it's an IBGP, this is a route reflector that is used. This is leaf 1, leaf 2, and leaf 3. The MAC move is happening from leaf 1 to leaf 2 and vice versa. And leaf 3 is just to showcase how a MAC move that is happening from leaf 1 to leaf 2 is as seen by leaf 3. What is the impact of MAC move on leaf 3? And I'm using an L2 switch in between to move the MAC moves. So this is how the use case looks like. Before we jump into the actual MAC moves, um, let me let me just show you the setup that I have. So this is spine, leaf 1 and leaf 2, and this is a L2 switch in between which I'm using, and this is a remote VTAP, and this is a host. Now on spine, I have 3 sessions that are running, 3 VTEPs, leaf 1, leaf 2, and leaf 3. As I told you before, this is an IBGP setup, and hence I'm using this as a route reflector. This is my RR. So let's see leaf 1 configurations. So the leaf 1 is my 1.24, 192.168, 1.24, and I have VNI 10 and VLAN 10. This is where I'm trying to move the MAC. This is from VNI 10. So it is between the same VLAN. So I have configured MAC mode detection count to be 3 for now, and have retained the timer value to be 180 seconds only. So that we can complete, I've lessered the number of moves and I've retained the counter timers. So as of now, there are 4 tunnels, as you can see. All of them are over L2 VNI. And this is a show MAC address, show MAC. Now, actually, the one which we are concerned is this. This is a host. I shall show you the configurations of the host also. The ending with 62 4F. This is a dynamic one which is learnt on leaf 1 now. And this is my show EVPN MAC IP. This actually prints the detailed version of show MAC with pertaining to EVPN. So this is the MAC that I'm concerned about now. It is learnt on VNI 10. This is the MAC. IP is, if at all IP is there, IP will be printed. And there's no next stop because this is a locally learnt one. And the sequence number is 0. So these are the flags which will be updated there. Also, you can check show BGP, L2 VPN, EVPN, which will give you a detailed output of from where the route is received and from whom it is received and for what VNI it is received. So you can check the detailed output in show BGP, L2 VPN, EVPN command. So now let's move to leaf 2. So this is my 192.168 1.21, and I have same similar configurations here also. Show run EVPN. I have here also I've configured a count of 3, and show EVPN MAC IP on leaf 2 looks like this. If you see here, this is a remotely learnt MAC, and it is pointing to leaf 1 1.24, similar with the show MAC address also. You can also use show BGP L2 VPN EVPN to see the the routes which are received. So these are the configurations. I shall just keep this ready here. Oh, this is my L2 switch where I'm going to simulate MACMO. So what I'm trying to do is interface 111 is attached to leaf 1 while 112 is attached to leaf 2. For the first move, I shall just delete VLAN access here and add it here so that you get a feel of MACMO there. So this is my remote VTAP. If you can see here, I shall show you how these MAC moves are seen from a remote VTAP. As of now, it is pointing to 1.24, which is nothing but my leaf 1. So show BGP, L2 VPN, EVPN. I shall just check the same thing here. So it is pointing to 1.24. So this is my host configurations. If config is, this is 013 and my hardware address is ending with 624F, and I've configured active gateway IP. This is a distributed gateway IP setup. So this is my active gateway IP which I've configured. So let's start with MacMo. I shall just monitor on one of the leaf so that we can complete all of the MacMos, which is 3 within 180 seconds. So I shall just see on leaf 2 how MacMo gets impacted. So this is my initial configs. Let's start with first MacMo. I am audible, right?
Yes, we hear you.
Okay, sure. I just wanted to confirm before starting off. Thanks. So let's start with first MacMo. Before that, uh, so this is what I wanted to explain before I move to MacMo. This is my leaf 1, 1.24. This is my leaf 2, 1.21. And this is how we see from leaf 3. So initially this is dynamic here and this is EVPN here. And leaf 3 is pointing to leaf 1. First move happens, we swap it. So this becomes EVPN and this becomes dynamic learn. And the leaf 3 will be pointing to leaf 2. And on the second move, 1.24 will have it as a dynamic one and 1.21 will have it as EVPN, and this will be pointing to leaf 1 on second move, leaf 3. Now on the third move, so from leaf 2's perspective, this is my first move, EVPN to dynamic first, this is my second, and this is my third move. So here third move is triggered by a local learning event. He already had an EVPN MAC and now he is learning a dynamic MAC, which means this is a third move. So he will dampen this MAC, dampen this dynamic, which means he will not advertise any route type 2 until the MAC dampening is cleared. So from leaf 3 would be pointing to leaf 1, which is 1.24 until the MAC dampening gets cleared on leaf 2. Once the MAC dampening is cleared on leaf 2, he'll start pointing to leaf 2. So this is the use case of what we are going to see in the demo now. So let's start with the first move. So as you can see here, this is my locally learned. The sequence number is changed to 1 here. I'll see on remote. The sequence number got updated to 1 and it is pointing to 1.21, which is nothing but my leaf 2. I'll do a second move now. So it is local here. I'm learning it as a remote. So this is my EVPN learnt MAC, which means if I do a show MAC here, this is learnt as a dynamic one. 62 4F is learnt. And here again he would shift to 2. If you see here, it is pointing to leaf 1 now. So we are done with 2 moves. Let's do the final move, which is the third move. So this is my third move. If you see here, it is still pointing to 1.24. Okay. And I shall show you the show MAC. As you can see here, it is showing it as a dynamically learned MAC, but he has not created any advertisement for that. Let's go and check the same thing in show BGP, L2VPN, EVPN. If you can see here, he has not generated any. These are all the routes which he is receiving. So which means that he has dampened the MAC. And if on show MAC, here also you can see the same thing. It is dynamic here also. On both leaf 1 and leaf 2, it is shown as dynamic now. Let's check on the other end. As you can see, it is still pointing to leaf 1. He has not received any update from leaf 2 yet. It is still pointing to 1.24. Okay. So now let's check the event logs. This is the first step to check. As you can see here, we are seeing EVPN duplicate MAC dampening detected for this MAC. So until it is cleared, you don't see any update on the other end. So by default, the timer is of 180 seconds, which I've retained. So until that is hit, the difference timer, whichever is hit, and the timer is MAC dampening is cleared, you will not see the remote host pointing to the correct VTEP. And one more thing is, we can also see this via the fast logs, like I showed you before. EVPN dump. It actually dumps the entire info. So this is how you dump it. But okay, this is cleared now. So this is a trap handler, which is marked as an error. So MAC trap is detected for this one, and it is also cleared, it says. So let's go and check here now. See, as you can see, it got updated to 1.21. Let's check on EVPN MAC IP also. See, if you can see here, the sequence number is now updated to 3 once the MAC dampening got cleared on leaf 2. So now let's check the event logs. So if you can see here, MAC dampening is cleared for this MAC. Now it is actually generating 1.21. So this is how MAC dampening works. Thank you.
Swati, I've got a question.
Yes, please.
In the show EVPN MAC IP, is there any plan to provide a flag with a D flag that would actually show the dump?
Yes. There's a plan, but we're not sure of. There's a dependency on the external team. So once they support it, we shall just integrate the same. Yes.
Okay,
We have a plan. Yes.
Yeah, that would be very practical for
Yes,
seeing
that's
actually
an
anyone.
open. Yes, that is open for now. Yes.
Okay, thank you.
Yeah.
Yeah.